Hi there, so we're looking today at more measures of spread. This time we've been looking at quartiles, haven't we, and interquartile range and percentile range. But now here's another big important one. It's called standard deviation. Also variance. The two are very closely linked, but we don't normally talk about variance. But before you have standard deviation, you have to calculate the variance, which is, you can think of it as how much the data is varying on average from the mean. So it's about how closely grouped your data is. It's a measure of that. But it's more useful to have the standard deviation. That's what we talk about, which just makes the amount of it a bit smaller, so that we can look at it in a way that, I don't know, just when you get used to it, it makes more sense. But it's basically just the square root of the variance. And we've got a little symbol for standard deviation being there. And then you'll have noticed all this stuff written in black down here. That is on the A-level formula booklet. So I want to refer to that all the time today so that you know how to use it. And there's a little beware, because most of it is at the bottom of page 3, and then you have to turn the page over to get what it really means for the important bit of the standard deviation there. So we'll now have a little look at an example or two to show how we use this. Okay, so here's our first example for you to note down. We've got 7 marks from a test for some students. And what we want to know is how much on average are they varying from what the mean is. So the mean would be what they all add up divided by how many of them there are, by 7. But we're not interested in what the mean is, but how far from that, how good is that average, how reliable is that average. So the variance, now if we look on here, it says that the standard deviation is the square root of the variance, and it says the standard deviation is the square root of s with the 2 little x's divided by n. And it tells you what that is there. So it never says exactly what the variance is, but it is all in here. So we need to do this and then divide it by n to get there. Now n is just how many values, the number of data points you've got. And to do this, this is the sum of all of our data squared individually, take away the sum of all of our data, then squared, divided by 7. What does that mean exactly? Well, I'll show you. So that's going to be all of these squared individually. 3 squared plus 4 squared plus 6 squared plus 2 squared, add 8 squared and another 8 squared, add 5 squared, and then that's all of that added together. And then we need to take away the sum of all of these added together. So 3 add 4 is 7, 13, 15, 20, 28, 36 squared divided by how many we've got, which is 7. And that should give you 230 divided by 7. But we want the variance, so if I write variance there, is going to be that divided by 7, which would be 233 divided by 49. If we put that into decimals, that would be 4.69 something. Yeah, to 3 significant figures. Standard deviation, therefore, I'm not going to write standard deviation, we use that symbol generally, it saves us a bit of time, is going to be that 230 over 49 rooted, which should give you 2.17 to 3 significant figures. Now you may say to yourself, is there anything we can do with the calculator about this? And yes, there is. I mean, it's better when we get more data in terms of saving time, but let's have a little look at it now. So we go to statistics mode, which is pressing 2. Once we've done that, we look at our data and we want 3, 4, 6, so we just put all of our marks in there, 2, 8, 8 and 5. Oh, and before we go any further, just check here, if you go to set with F6, you see we've got an X list, so that's just our list of our X's, of what our data is, so that's fine in list 1, and then it says 1 var frequency as list 2, so we've got our frequencies as list 2, so I need to go back, and we've got one of each of these, so if I put a 1, if I don't do this I just get an error. If I go 1, 1, 1, 1, 1, I've got one of all of those data points. Now if I press 1 var, I get all of this information, and notice I've been using this symbol here, the standard deviation, that says 2.1665, so it's worked it out along with a whole load of other things. X bar, by the way, in case you're not sure, is the mean, so adding them all up and dividing by 7 is what that is. This is adding them all up, gets us 36 that we talked about there. Adding them, the square of all of them up, summing the squareds is 218. That's in there as well. That was something we did earlier, but it was all of those, wasn't it? Anyway, that lots of information. How many data points we've got is 7, and so on. Anyway, time for another example. Okay, here's some more data. So this is how much time people have been spending out of school. In minutes, we've got 3 people on 35, 17 on 36, 29 on 37, and 34 on 38. So, see if you can work out what the standard deviation of that is. So first of all we need the variance, don't we? So the variance is going to be all of this divided by, and so we start off with 3 times 35 squared plus 17 times 36 squared plus 29 times 37 squared plus 34 times 38 squared, all of that. From that we take away what the sum of them all squared is, divided by how many there are, meaning what we're going to have to do is 3 times 35 plus 17 times 36 plus 29 times 37 plus 34 times 38 and square that, divide it by how many we've got, which is 83 if we add up our frequencies, and then once we've done all of that we need to divide all of that by how many data points we've got again, which is 83. Okay, and then the standard deviation is going to be the square root of that. So if you plug all of that into your calculator, you should get 0.74147. Square root that should give you 0.861. However, entering all of that's a real pain, isn't it, like that? So let's have a little look at how we would do it using the calculator. So remember, we go to statistics mode, mode 2, and I want, my first number is going to be 35, then I've got 36, then I've got 37, then I've got 38, then I just need to delete the other ones that I've got there. Then I go across to the other list and I want 3 of the 35s, 17 of the 36s, 29 of the 37s, 34 of the 38s, and I'll just delete those. Right, now press calculate, gets us to there, and then 1 var, and we should find the same number that we just got there. So the standard deviation being 0.861. Happy days, folks, and if you needed the mean, there it is, 37.13. Right, well, the one kind of data we haven't looked at yet today is continuous data, which is the one that comes up the most because it's anything that gets measured. So we need to do that. There's also, you may have noticed, as well as working out the standard deviation the way we had been doing before, or the variance the way we had been doing before, there's another slight variation that can be a bit quicker here. So we'll do this using this way as well as doing it on the calculator. So we need to have all of our, it's always an estimate of course when it's grouped data like this is, and we're going to have to be taking the midpoints. So we're going to want here the sum of the values squared divided by n, take away whatever the mean is squared. So the first thing we'd need, so to do that one, we would need to do the value. So the values all have to be taken as the midpoint. So this would be 4 times 2.5 squared, add 15 times 7.5 squared, add 5 times 12.5 squared, add 2 lots of 17.5 squared, nothing for those ones, so I'm just going to ignore that, plus 1 of 65, exactly halfway between those. Right, so that 65 squared, sorry, all divided by how many we've got, so that's 19, 24, 26, 27 lengths have been taken. And then from that we're going to have to take the mean squared. So the mean is just going to be all of these without the squares, which should look like that. So once we've taken that away, we will then just need to do the square root of all that. And if we put all of that into the calculator, you should get, so to be honest, I haven't actually put it into the calculator, that's just what it said. So let's see if we can just take the shortcut and go in the calculator and see if we do end up with 11.35. So first thing is just to delete all of those, although to be honest they will delete because we've got more of them if I just go. So what I have to do is I do have to do the halving bit myself of the finding the midpoints. I mean, so I just do 2.5, I'll do 7.5, 12.5, 17.5, 40, but there's none there, and then 65. And go back up to the top here, and let's get the frequencies in. 4, 15, 5, 2, and 1. Now if I hit 1 var, there we go, we've got our standard deviation being that. So I put that down as my working, but all I have to do is whack that into the calculator. So if it doesn't ask you to show how you got there and you're in a hurry in the exam, just whack it into the calculator, but you should really show you're working. Right, first practice question for you to have a go at. Pause it as ever, have a little look at the formula and give it a go. So the bit of the formula booklet you wanted was on the second part where it says standard deviation. It says it's got 2 different formulas. It's got that one and it's got this one. You can do this one if you look back at the other page, but you can do it all from here. And you may think, well, I I'm not so sure that you can. I mean, you may think, oh yes, I've got the sum of the W squareds. The weight squared of the 10 dogs is 5,905. I divide that by the number of dogs we've got, which is 10. Then I'm going to be taking away the mean squared. Now, the mean is all of them added together divided by how many there are. Well, this is all of them added together, so the mean is going to be 241 divided by 10. So that is, well, I know that's 24.1. That is that squared. So that's what we need to chuck into the calculator, like this. And that gives you root 969 over 10, hit S to D, and it gives us 3.11 kilograms to 3 significant figures. Okay, just one more question to go. So there wasn't that much going on in that question, but there's plenty in this one. So pause the video, have a good read, take your time, sort it out, and then come back and see if you agree with me. Right, well, first of all, it wants to know if 90% lasted longer than one standard deviation below the mean. So the first thing we need to know is what's the mean, and then what the flip do we mean by one standard deviation below it. Hopefully you've had a thought about it. It's the only thing it really could be, but so if you think you want to have another go, then pause it and have a go now. Anyway, for the mean, you should have done this working. Or you should have gone to your calculator and gone menu, statistics. Let's see how quickly we can do this. So we want the midpoints of each group. So that's 7.5, 12.5, 17.5, 22.5, 27.5, and then go up to here and get our frequencies in 5, 14, 23, 6 and 2, and then press calculate and go one var, and that's giving us our mean as being 16.1, and it's worked out our standard deviation, which you could do using the formula, and that should have given you 4.69 to 3 significant figures. And what that means is one standard deviation below the mean. It's literally just the mean is at 16.1. One standard deviation below is what happens when you take one lot of 4.69 off there, which gives us 11.41. Now what is 11.41? It's hours, isn't it? Now 11.41 is somewhere in here, isn't it? And what we need to know is, did 90% of them last longer than that? Well, we're going to need to do a little bit of interpolation to find 90%. So if you hadn't thought of doing that, do interpolation to find 90% of them now, pause it, and then carry on. And when I say 90%, actually you want to find 10%, don't you? Because 90% will then go beyond there. So it's the 10th percentile that you need to find. Do that now. Oh, and actually looking at it, I've just started. 10% of 50 is 5. I don't need to do the percent, I think, because it's fallen right there. So that means I know that 45 are 90%, and 45 have gone to 10, haven't they? So how many have got to there? What percentile is 11.41? I suppose we should work that out. I guess we're going to have to work backwards there a little bit. I'm going to be saying, right, I don't know how far through those 14 we are, but the class width is 5, so how far through that? And then I would have added that to 10, and it's got me 11.41. So first of all, I'm going to take the 10 away, and then I've got x over 14 times 5 equals 1.41. And then if I divide by 5 but multiply by 14, so I'm going to do both, divide by 5 and then times by 14. Let's do that now. 1.41 divided by 5 equals times by 14 equals x is 3.948. So it's that far through. So that's like the 5 plus 3 is like the 8.9th one, so almost 9. Take that away from the 50 that you've got. 50 take 5, and then take the, and that is take 8.9 is, it's going to be 41.05, isn't it? So actually you've only got 41 out of 50 doing that, not 90%. So your comment on the accuracy would have to be to say that the manufacturer's claim is false because they've only got 80 something percent, not 90%. In fact, we can work out what percentage it is if we divide that by 50, can't we? Divide it by 50, and that equals 0.821, so that equals 82%, not 90%. Okay, you might want to listen to that back through again, just to get it right. Anyway, there's plenty more practice to be found in the books on those, so good luck with that, folks. Cheerio!